In the prior lesson, we learned how to use synthetic division to determine whether something was a factor of a polynomial function or not, or use the remainder theorem to write the remainder. Now, in this particular lesson, we're going to work on finding all of the rational zeros of a polynomial function, and of course synthetic division will become a part of that. Now, before we even start, one of the things that we need to be aware of is how many zeros does the polynomial function have. Now, keep in mind, you can have rational zeros or you can have imaginary or complex number zeros. For this particular lesson, we're just going to focus on the rational zeros, and in subsequent lessons we're going to focus on irrational zeros and complex numbers. So for this particular lesson, we need to kind of have an idea already of how many zeros are possible, and we have two little theorems here that kind of give us that information. The first one is the fundamental theorem of algebra, and as you can see, it basically says if the degree is positive for the polynomial, which it should be, then it has at least one zero in the set of complex numbers. Now, that really doesn't narrow it down for us all that much. We kind of figure it's going to have at least one zero, but it is stated in that theorem. The second theorem is something that we've informally discussed, and that's the nth root theorem, which tells us that whatever the degree of the polynomial is, it can have up to that number of zeros in the polynomial function. And we know that if we're solving equations, that's the number of solutions that we're looking for, but it doesn't necessarily have to have that many zeros. So let's take a look here how we're going to kind of use this, and you can see these steps for finding all of the factors of a polynomial function. So that's what we're going to focus on in this particular lesson. Basically, we have three steps. We're going to use the synthetic division multiple times if necessary, and what we mean by that is if it's given multiplicity. And if you recall, multiplicity means that the particular zero that we're working with, could happen more than once. And so we're going to use synthetic division as many times as it tells us to for that particular given zero. Then we're going to hopefully whittle down whatever our higher degree polynomial is to a quadratic, and then just simply factor the quadratic. And then we're going to write the polynomial function as a product of those linear factors. Now, what we eventually will use this system for, which we'll use this process for, is to eventually solve polynomial equations in later sections. So let's take a look at a sample problem here. And if you look at sample problem 1, what I'll do is I'll work through sample problem 1 with you, and then I'll let you work sample problem 2 on your own, and we'll see how you do with that one. So let's take a look at what it's asking us to do. It says write the polynomial function in factored form given one of the factors. Now, if you recall, it gives us a factor c equals to 3. So if you recall, we were doing x minus c, so in this case that's x minus 3, but the c, the 3 value, was the value that we were using for the synthetic division. So we want to see, we know we're being told that it's a factor, so we want to go ahead and find the depressed polynomial and see if we can factor it any further as well. So let's go ahead and use the factor that's given to us. So you can see I've now set up the synthetic division with the given factor and the coefficients of the polynomial, and now I'm going to go ahead and work this forward. And you can see here we've done the synthetic division, and we knew that it was a factor, so that gave us a remainder of 0, and it's going to give us the depressed polynomial. If you remember, that is 1 degree less than the given degree, and we just work that down. And so we can see here that x minus 3 is a factor, and the depressed polynomial as a result of that is what's left over. Now we need to follow the next step. We've got a quadratic at this point, and we need to factor that quadratic if we can. So I'll go ahead and work on that next. So if we look at this quadratic that's given to us, we have a leading coefficient greater than 1. So this would lend itself to grouping, and so we'll just go through the grouping process that you remember from quadratics unit. Now that I've factored that quadratic, I can go ahead and write the polynomial, the final polynomial, as a list of its linear factors, and so I'm going to go ahead and do that. And that was what we were looking for in the end. Now, if this were an equation, a polynomial equation, and the f of x was equal to 0, we can now set each of these equal to 0 based off the zero product property and actually find all of the solutions to this particular problem. So this is a lead-in to what you'll eventually have to do when solving polynomial functions. Okay, in the next lesson, or excuse me, in the next video, I'm going to come back and we're going to work on sample problem 2.